Right, so the modes on the calculator, there are 9 different modes. There's normal, stat. Normal does things like fractions, integers, your trigonometry, probability. There's a random function, your constants, your conversions, all of that sort of stuff. Stats I will show you in a few. And that's got your linear regression and your basic stats. Table is just awesome. And we're going to be using a lot of table today in the work that we're doing. I want to show you how to use the table mode to teach a present value annuity and finance. And then, of course, to teach factorizing as well. And then, of course, complex numbers, which we'll go through briefly, the equation solver, and then your matrices, which we'll cover today. Vectors is this physical sciences and maths, applied maths thing, but I think we don't cover it in the topics of AP Maths. When I was looking through, I didn't see anything like that. There is a distribution, and then, of course, the mental maths drill, and that's just really great for practicing your mental maths, which I'm not going to go through today. So some cool new functions. You've all seen prime factorization before. It has now been added to the EL-W506. So I'm not going to do the example here with you. What I do want to show you the example for is the highest factor on your calculator. So say, for example, we have 54 and 72. And we want to find the highest common factor of these two. So we use second function and GCD. And you'll see it says GCD over there. And GCD is just greatest common divisor, which means exactly the same thing as highest common factor. And then, of course, 72 and equals. And so our highest common factor of 54 and 72 is 18. And we can add as many numbers as we like to this row. There you go. Let's add another one. I'm just making it nonsense here and hoping it'll work. But there you go. So you can see, you can just keep adding and really it will keep working. I mean, I've done the entire row where I've run out of characters and it still works. So at least you know that's an option. I can't imagine you'd ever need 60 odd numbers, but hey, I'm sorry. Oh, who else is suffering with crazy allergies at the moment? It is insane. Anyway, I digress. So let's look at the lowest common multiple, which is another nice thing, and that's just on 3. So it's just second function 3, and we can type in 72. And the lowest common multiple of 54 and 72 is 260. So this is really nice when we start teaching fractions and we're looking for the lowest common denominator, which is exactly the same thing as lowest common multiple. And again, you can just do as many as you can fit into that line of character text. So we could do 84, and you'll see it will just obviously make your LCM higher and higher depending on the values that you use. Okay, so that's those two functions. The next thing that I want to show you is the shortcut for your class marks. And this is such a nice, handy thing to know. And you can teach it to all your teacher friends at school. It will work on any Sharp calculator if you follow the steps. So basically, what you're going to do is at the top of your fraction, you're going to convert, you're going to put the value that you want to convert your total to. So in other words, if our test was set and it was out of 70, and we wanted to convert all of our marks to percentages, so something out of a total of 100. At the top, we're going to type in 100. At the bottom, we're going to add the 70, like so. See. Then we're going to say times, and we're going to put in our first student's mark. So there we go. And he gets 57 and 57%. Okay. Now your next student's mark, all you're going to do is type in their mark. So we're just going to say 55 and equals. And now we get 78, or if we round it off, 79%. And your next students, again, you just type in 23 and equals. And you'll see that K is actually that ratio of 100 over 70 multiplied by your mark. And so we get 33%. And again, you can just keep going until you run out of marks to type in. And you can see that it is really so quick and easy. I mean, it should take you 5 minutes to do all of the mark conversions. And you can apply this to anything. So if you have, for example, a project that now needs to count out of 30, but your original mark said was at 100. So then what you would do is if we are converting to a total of 30, And our original set of marks was out of 100. So then we say times, and let's say our first student got 56 out of 100. He now gets 16.8, or, sorry, I did that too fast, or basically 17 out of 30. Okay, so it's as easy as knowing where you want to go to, where you're coming from, times the student's mark, and then just mark equals, mark equals, mark equals until you are done. So really a nice handy function. And for those who are not maths teachers and don't have a Sharp scientific calculator, if you have a basic Sharp calculator, so anything from our junior 231 GPGB all the way through to the pretty pink and blue ones, all you would do is say, what am I going to divided by what did I start with equals times the first mark equals, and then mark equals, and so on and so forth. So it works exactly the same way. Just give me a second, guys. Sorry. Sorry, we have been cutting the grass at home, and I tell you, I should live in a bubble. Anyway, let's move on. So the next thing that I want to show you is a really nice way to convert between degrees and radians. Okay, so we're going to turn that on. You'll see your calculator is automatically set to degrees. Okay, so what we can do is if we have 30 degrees and we want to convert it into radians, we can say second function and dot, and that will give us 2 radians. And you'll see above here it says DRG arrow. So it just cycles between degrees, radians, and gradients. And so now we have it's set in radians. So what we can do is say I have pi over 4 radians, and I want to now know degrees. So I can say second function, and that will give me gradients. And again, second function, and now I have 45 degrees. Which, if we think about it as 2 pi is equal to 180, I think it is. Oh, 2 pi is equal to 360, something like that. Then you can convert it back like that as well. Now, you can make your life easier by actually saving that shortcut into your shortcut key. So these are just function keys that allow you to save a function that you like using all the time that requires more than 2 buttons. Okay, and so Paul, yes, you did miss that. So what I will do is I'll just show you again how to download the simulator. Just give me a second. Let me show you again. Okay. So here on Maths at Sharp, if you just go to maths@sharp.co.za, the first screen you're going to see is the Merry Christmas one. Okay. And then all you do is use your arrow keys and scroll across. And there you go. There's your download now button. So you just click download now and give it a moment. And then just choose where you want to save it to. You can say, I've already saved mine. So once I've done that, I'm not going to save it now, but you should save it. And then what you'll see on your desktop is this. Okay, and just a hint, if you are using Zoom with your students, so you'll see now I'm sharing my entire screen with you, and you can see the mess behind it. So what I normally do is I share only the function that I'm working on at the moment. Also, it helps to keep them focused, and you don't lose everything around it. Your attention is only on that one thing. Okay, so back to the degrees and radians. So we saved it in here. So if, for example, I now have 90 degrees and I want to convert them to radians, I can just press D1. Oh dear, did I turn the calculator back on? Okay, let me save it again. So store D1, second function and dot. And now you'll see if I say 90 degrees and D1, it will convert it straight away into radians. So it is 2 pi is equal to 360 degrees. All righty, cool. We all happy with that? Making sense? Wonderful, wonderful, wonderful. Okay, so leading on from degrees and radians is obviously your time question. Oh yeah, I need a bubble. Okay, sorry guys. There's nothing worse than hearing a presenter sniffing at you all the time. Okay, so what are we going to do is I just want to walk you through the various functions. So the first one is, let's say, for example, you have 470 minutes and you want to know how many hours that is. Okay, so what we'll do is we'll say 0 in the hours placeholder, press our DMS button, it says degrees, minutes, seconds, and luckily it works exactly the same way as hours, minutes, seconds. It uses the same sexagesimal system. And so you'll have 470 and just simply equals, and then it will convert it for you. So it's 7 hours and 50 minutes. And if you wanted just an hour notation, you can say second function and DMS. And there it is. So 7 and 5/6 of an hour, close to 8 hours, if we were looking at that. Now, the other nice example that you can do is how long does it take me to get somewhere? So if I travel 500 kilometers an hour, I would have to be an airplane to do that. If I travel 500 kilometers and I do an average speed of 114 kilometers per hour, how long will it take me? It's 4 hours and 22:57. And if I change it 4 hours, then I'm going to guess about 20, 25 minutes. Okay. But we can know for sure by pressing second function and DMS, and 4 hours, 23 minutes, and 9.4737 seconds. Okay, so that's the next one. And the last one, which I, funnily enough, have been using quite a lot, is the time calculation function. So the Susie train station question. Susie gets on the train at 9:45. She gets off at 12:30. How long was she on the train for? So we use our later time first, so 12:30. We say minus, and we say 9:45 because it was 9:45, and equals, and it's 2 hours and 45 minutes, and we can convert it back 2 3/4 of an hour. See, I'm still in radians, so I just want to change back here because otherwise I'll be in big trouble. Okay, so those are the various ways that you can do time calculations. Are there any questions here? All right, let's move on to the fun stuff. Okay, so for an IEB math syllabus, you are allowed to use the EL-W506, which is this calculator here. It has the equation solver. If, however, you are teaching maths at a DBE school, you cannot use this calculator because of the equation solver. So just be aware of that difference. Okay, so let's start with just doing a definite integral. All right, so we'll start with -3 at the bottom, and we'll go from -3 to 6. And in here, where we type our integral, to make an x, we just press RCL twice, and it's called cubed. I'm making up stuff here, so it won't match the example that I've typed up. But it's always good to know that you can do it with whatever you like. And equals. And you'll see the little busy sign. So depending on the how complicated your question is, will depend on how long it takes to get to that answer. And there you go. So the area under the curve between 6 and -3 of this cubic graph is 281 units squared. Okay. Now, the other thing that you can do is also find the differential at a point. So your gradient at that point, in fact. So let's say alpha, and you'll see next to integral is your differential. And again, you just type in whatever your graph is. I'm just going to use the same one. Like so. And we'll just say at the point where x is equal to 2. And equals. And you'll see here, it gives you 0.0005. So actually the answer is 15, but because it's using a Newtonian method to work out the answer, you will get this. It's actually just your error. If we rounded it off, we would see it's 15 anyway. So just be aware of that fact and make your students aware that they don't need to write this section down. The answer is actually 15. And in fact, they should be able to find the differential of this. It should just be a checking mechanism. Now, from here, I did the complicated calculus first, but what I want to show you is the gradient at a point and move on from there and then look at drawing the graphs. So when I first set this up, I thought, I am so clever. we're going to do gradient at a point using linear regression. And then I did it on Tuesday morning with maths group, and I thought, my goodness, this is a long way to do something. And you can see, look how long it takes to get to this point where our gradient, which is what we're actually looking for in this entire exercise, is 3. So my feeling is rather just type it in using the formula, because it will save you so much more time. I mean, look, that's the steps, that's it. So unless you have a student who mixes up the y's and the x's and doesn't know where to substitute, and you'll see here when they do it, they have to put the coordinates together so that it works correctly. They have to type in the coordinate as a coordinate. And then that makes it a lot harder to mix it up and get this part wrong. So if you have students who tend to do that, then I'd use the other method. But otherwise, I just use this way because it's so much shorter. That is my high horse for today. You know, a calculator is wonderful, and you can find all of these things that you think are shortcuts, and actually they're not. So yeah, just to be cognizant of the fact that sometimes what you think is a shortcut is not actually a shortcut. So now what I want to do is I want to move across to our table, and I want to look at a calculus graph. Okay, so we've got x cubed plus 13x. Now I took this from an example on one of our worksheets, so I know that it gives me perfect roots. Okay, x minus 40. Okay, so that is my calculus graph, and I'm going to just ignore function 2 for now. I'm going to come back to it in a little bit, and I'm going to say equals. And again, I'm just going to leave my start and my step at 0 and 1. Very lazy. And so there's your y-intercept at -48. Here is my first x-intercept. Okay, so when x is equal to 1, y is 0. And so I know that my first factor is x minus 1. Now, if I scroll down the table, you'll see that very quickly my y values are just growing astronomically. So I'm actually just going to leave that. I'm clearly not going in the right direction for this graph. I'm just going to go this way instead. And even though we started at 0, you can go back up into the negative side. So it doesn't matter where you start or what the value of your step is, your table is unlimited, which makes teaching lots of things lots of fun. And I'll show you that in a few seconds as well. So we're looking for another place where your y is 0. So here it is, x is equal to -6. So we know that the factor is x is equal to -6. We bring the -6 back across to the x, and we have x plus 6. And if we go back up, we'll see again, x is equal to -8. So my factor is x plus 8. Okay, and we can scroll, and you'll see now it just heads up into the negatives again as well. So what I want to do from there is actually look, and sorry, these steps are all here, and I will send this presentation to you once it's done, and a link to the recording so that you can watch it again if you feel like you need to. So what I've done is I've actually taken the derivative of this calculus graph, that's the next step here, and I've put it here. And what I want to do is actually add it here. So I'm going to leave my calculus graph as is and just press equals. And into my function 2, I'm going to put my derivative graph. Like so. Okay. And again, start and step as is. And if we go and look now at our gradient, because that's what this is, at each point. So in other words, when x is equal to 2, my gradient is 98. When x is equal to 3, my gradient is 139. That's really what it's showing us here. And so we can just scroll through the table, and you can see my gradient is just getting very, very steep. So that's 681 up over 1 across. I mean, that's a huge leap. And you'll see it just keeps getting higher and higher. And if we go and look at this side, so we're actually looking for our stationary points. And you'll see here, there's the change between 11 and -6. So we know our stationary point is somewhere between x is equal to -1 and x is equal to -2. And if we keep going, see, again, there's a change between -7 and -8. And we know that our graph is now going positive again. And you'll see it will just, again, increase astronomically. So what we're actually doing is we're showing the students this part of the graph. So we always do this part here. We do this little here. But what's actually happening is this is going down like that with that gradient, and that's going up like that. So we show them here with the 2 stationary points and our x-intercepts for the 3, but they don't see this part of the graph, and it's actually quite an interesting thing to look at, and just show them that graphs are actually beyond that tiny little scope that we look at as well. Any questions here? Are we all happy? Haven't put you to sleep yet. Oh, why have I done that? I don't want to do that. We all good? Okay, sweet. All right. So what I did is I took an example from the handbook and study guide from Kevin Smith for maths in grade 12. And we looked at question 3. I think it's question 3. And so the question is, the volume of water in a rainwater collection tank T minutes after it starts to empty is given by the equation VT is equal to 4 times 5 minus T squared, where volume is measured in liters. So determine the initial volume of the water in the tank. So let's go through to the first one. So initial volume here is the fact that T must be 0, because at the start, when your time hasn't started yet, initial beginning. And so all we do is substitute T or the 0 into your equation, and you get this answer, which is 100. You can type it into the calculator, but we all know 5 minus 0 is 5. 5 squared is 25, and 25 times 4 is 100. So if your mental maths is strong, then you shouldn't need to do this. But everybody's got their own safe place. At what rate is the water in the tank changing after 180 seconds? Now remember, the question was given to us in minutes, and now the time is given to us in seconds. And I'll come back to that in a sec. So the key word here is rate, and we know that we have to find the derivative, because derivative gives us rate. So here we're going to first multiply out. I fixed it. There you go. And so our final equation before we take the derivative is 100 minus 40t plus 4t squared. So you can see if t is 0, it will give us 100 as well. And then if we differentiate, 100 is 0, and then negative 40t becomes negative 40, and plus 4t squared becomes 8t. And so now what we would do is we need to change the 180. Oh, you see, I didn't fix that. 180 seconds into 3 minutes, and we substitute the 3 minutes in. And you can see when I first did this question, and as I was setting up the workshop, I substituted in 180 seconds because I didn't read the question nicely. And I was like, why? It can't lose this much water that fast. I mean, that's just crazy. It would be dry already. So that rate doesn't make sense. And then I went and read the question, and I was like, okay, it's in minutes and not in seconds. And so you can see it's losing water at a rate of 16 liters per minute. Now, the last question in this example is, how long will it take for the tank to empty? So we want to know what time it will take when the volume of the water reaches 0. So all we're doing is substituting 0 into your VT and solving for T, which gives us 5 minutes. And here you can see I actually plugged it into the table mode of the calculator just to show you what that graph would look like. So that's how much water is left in the tank after 1 minute, after 2 minutes, after 3 minutes, after 4 minutes, and at 0 minutes. All right, any questions there? Are we all happy? If you're good, just wave your hand at me so that I know that you're still awake. Yay, thanks, Christine. Awesome, thanks, guys. I appreciate that. Oh, good, everyone is waving. Okay, so you're all still there and with me. Fantastic, thanks, everybody. So what we're going to do is we're going to look at complex numbers. Now, complex numbers is quite easy, and for what you have to do with it in the syllabus, it's not too complicated at all. So you don't need to know too much. So the first thing I want to point out to you is that your calculator is automatically set to rectangular coordinates. In other words, your I. So if I have 3 minus I, your I is just on your DMS button. You can see it in gray there. You'll see what happens with the calculator is that it separates it into real and imaginary numbers. Now we can also change from that into our hypotenuse and angle. So our hypotenuse is 3.16 and the angle is -18. So it's going down this side. Okay. And again, we can just change it back again to X and Y. I see this question. Paul is asking if we can please share the manual. Yes, Paul, if you'd like the manual, I'm happy to send it to you. Won't you just send me a mail after this and I'll send you back the manual as well. Okay. So that's the other thing. And then the last really thing that you need to know is that you can get your conjugate value, which I mean is pretty standard. It's just the opposite negative. You just changing the sign of the I. So there's your conjugate value. But again, you can also just change between the two signs. And you can also type in, you have your hypotenuse, here is your angle, and let's say it's 30 degrees, and you now want it in rectangular coordinates, then you can just say second function and 9, and it just gives it across like that to you. So you've got both ways. It's very, very easy to change backwards and forwards. Before I forget, and I see I didn't add it in here, but there is a really nice shortcut for Pythagoras. And if you're teaching trigonometry, the P coordinates on your Cartesian plane. So say, for example, the X is 5, and it's that button, and your Y is 12, and we want the hypotenuse and the angle. We're going to use that same functionality that we used in complex numbers, except we are using it on real numbers. So our hypotenuse is 13, and the angle the hypotenuse makes is 67. See, there's another question here. Okay, it's a pleasure, Paul. Okay, great. So that's pretty much what complex numbers boils down to on the calculator. You can see all of the different examples here, and the real and imaginary. So the calculator will actually just give you the real version and the imaginary if you type in a complex value. Okay. The next thing that I want to show you is the absolute value graph. So we're going to go back to table and we're going to just do an absolute value graph, just a very simple one, just to demonstrate it. As 3, okay, and equals leave function 2, leave those as is. And you can see as you scroll up, it's just increasing by 1 the whole time because it's 3 plus 1. And if I look here, at 0, it's 3, which is your y-intercept. And then again, it increases in a mirror image on that side. So you get that beautiful triangular graph. So that's a really nice one, just to show your students what an absolute graph looks like. Now, the next thing that I want to show you is the tan graph, which is also really fun. So if I put in a tan graph, and I'm just going to do a basic one for now, and I press equals, I'll leave my start at 0 for now, but I'll make my step 15 this time, just because 1 would take you a really long time to get to anything. Would just be a time waste, basically. So you can see it gives you just the various increments of the 15 degrees. And the reason I choose 15 for trig graphs is because when you start shifting the graphs, you can start to see the shift taking place in spots other than 45. So if I go back and let me edit this. So let's say we shifted 30 degrees. You can see now my 1 is at 15 instead of at 45. And if I go look for my asymptote is now at 60 instead of at 90. And the asymptote actually looks like an asymptote, which is really nice. And then if I scroll down, you'll see your table will just go on and on and on, and the values will just keep repeating again and again and again. And it's really nice to show this to your students and explain where the cost diagram comes from. Delene, I will definitely send you the recording. Thanks so much. Awesome. So that's graphs. Let me show you some statistics very quickly. So I'm not going to use the examples from the presentation that I've done because I just want to run through them. So sorry, let me do that again. So mode, and then 1 for stats, and you'll see you have this big menu. We use mostly the single data, which is just that 0, and the 1 for linear regression. You can also use 2 as a shortcut to find your second common differences pattern. Length, everybody. I will send you a link to the recording on Monday once they are all uploaded onto our YouTube channel. So I promise you'll get one. Okay. So let's start with basics. So all you have to do is type in values and press equals. Okay. So you did a pretty good job. Your students performed really well. No, that's a terrible mark. Cool. Okay, so we've got 9 different values. Once we're done, we just press change. And you can see you can just change between the 2 screens really easy. Now, what I want to show you here is, say, for example, you come back and you see that that is actually the wrong value. You should have typed in 41. All you do is highlight the value that you want to change, type over it, and press equals. And now you can see it's changed to 41. So really nice and easy to change it. And for stats, it's as simple as 1, 2, 3. Done. So there's your number of observations. The average of your class marks was 62,663 or 63. We don't use this SX. We use sigma X for our standard deviation. So it's 20.28. The sum of X of all of your marks, you know, for those forms we always have to fill in your minimum, quartile 1, median, quartile 2, and maximum. So everything is there ready for you to use. Now for linear regression, it works very similarly, except you have a coordinate that you now need to enter into the thing. So there's 2 ways to put in your data. The first is to type in your X's and then go back and type in your Y's. Okay, I don't like that way because what's happening here is you're seeing the values as 2 separate things. And that's not what a scatter plot is. It's actually a coordinate pair. So firstly, I don't like it for that reason. And secondly, because if you are entering them as coordinate pairs, you are much less likely to make a mistake. And you'll make sure that they actually line up with the correct X. You know, when we're in a hurry and we're doing stuff, sometimes we don't always pay attention, and so we lose that. So to repeat that, all you do is type in your X, press this X, Y button we used for Pythagoras, type in your Y. I've done a perfect line now, so it should give us 1 and equals. And you'll see it will just fill it in across the graph, the table for us. So I feel like that way is a safer, neater way to do it. My stats background definitely makes me more pedantic about this sort of stuff. Just okay. So from there, if we press alpha and H, you'll see above 8 in blue it says stat, and so that we just know it's alpha 8 to get to our statistics menu. Again, if we press 0, it will give us all of our summary statistics for X and then for Y as well. Okay, so it's all there, including all of those sums with X cubes and to power 4. If you're doing hectic stats, that's very handy to have. So now we want the line for linear regression. So we're just going to say alpha and 8, and we can see 1 says regression values. So we just press 1, and here is our line. So we know our y-intercept is 0, our gradient is 3, and our correlation coefficient is 1. And that's because I did perfect values. But that won't always be the case, and it's something to pay attention to as well. So everything is there for you, easy peasy. Then that's pretty much stats. Is everyone happy with stats? We're all good. Here's another example so that you can look at it once you're done. Awesome, thanks guys. Okay, distribution mode. I just wanted to put it in here. I don't know because I think the stats is a selection module on AP Maths, so you don't necessarily have to do it. But I just wanted to show you that you can actually have access to a normal binomial and Poisson distribution. And you can do your probability density function, cumulative density function, and your inverse as well. And then, of course, if you want to just type in your X, your mean, and your sigma, it will give you your probability of that specific value, depending on what you're using. Thank you, Guka. I'm glad you think it's great and wise. That's awesome. So that's basically the distribution mode. I want to show you now the finance. So I'm going to skip through the simple interest and compound interest. And what I want to show you now is actually decay, which works exactly the same way. So it would just be repeating itself. So we're going to go back to table mode. And what I want to show you is, say, for example, we have simple decay. So we have 1,000 Rand, and we're going to call it 10%, right? Over 100 times, and we put in our X for the end value and close our brackets. Okay. I'm going to leave, let's put in our compound interest at the same time. So here's our compound decay, 1 minus 10%, close the brackets to the power of X. So both X's are representing our number of years. And so what we're going to do is, you can see here where we decay, the first year it decays at exactly the same rate, 100 Rand. But here at the second year, your simple decay still decays at 100 Rand, but your compound decay is only decaying at 90 Rand. And if I continue down, still 100 Rand, but on this side, I've only lost 81 Rand. Do you see? And so what's happening is, if you have a value for something, you want to use compound decay because obviously your value will remain higher for longer. And of course, we can see here it's lost completely value at simple decay, but at this one, it's just going to keep slowly losing value and reach a limit of 0 eventually. Okay, so that's a nice way to show your students. Now from here, what's really nice is to go into your present value annuities. And so I want to show you some really cool stuff here. We had such a great discussion on this yesterday as well. So what I'm going to do is, in place of my payment amount, I'm going to put an X, and then I'm going to fill in the rest of the formula. 1 plus 10 over 100, compounded monthly, close brackets to the power of negative, and we're going to use 5 years, and again it's compounded monthly, close brackets, and here we go, 10 over 100 compounded monthly. Okay, so it's a very long formula. I'm just going to delete that compound decay, and let's just use the step of 1 because I just want to make a point. So what you're doing here is you're actually just saying I can pay back 1 Rand a month, and that is how much you can borrow over 5 years at paying back 1 Rand a month. If I can pay back 2 Rand a month, I can borrow 94 Rand. Now that seems a little extreme. So what I'm going to do is I'm going to go and change my step to something like 100. Okay. And now we can go through. So if I can pay back 200 Rand a month, I can now borrow 9,400 Rand. And if I can pay back 500 Rand a month, I can borrow 23,500 Rand over those 5 years, and so on. So you can look at your budget and say, okay, my budget is I can spend 1,500 Rand, therefore I can borrow 70,600 Rand. And look here at the difference between, say, 2,900 Rand, which I get 136,500, and 3,000 Rand, where I get 141,000. And the difference is almost 5,000 Rand. So you can see, actually, and if we look at future values, that would also be something here. So if you add an extra 100 Rand to your savings, you're gaining so much extra in interest, along with just putting that extra 100 Rand into your savings. Okay, so that's present value annuities. Now, one of the really great, I shouldn't have done that. A really great question we got asked yesterday was, how can I use this to find my N? And the answer is yes, you can. So what you would do is, say, for example, your present value that you've borrowed is 100,000, right? So all we're going to do is take the formula all across to one side. And let's say your monthly repayments are 1,500 Rand. Okay, and then you're just going to fill in the formula as we did before, which is why I'm silly for deleting it. We'll call it 10%. Again, compounded monthly to the power of, and here what we're going to do is put in an X. Okay, And I'm going to leave it just as X without the 12 so that we're not working out the number of years, we're working on the number of months. And close that. And here again, it's just 10 over 100 times 12. And so what we've done here is, let's make our steps 1 again, is we're actually looking at our payments over each month. So that's how much, 3 months in, I've paid 1,500 times 4. This is my capital that I have left to pay. And if I keep going, eventually we're going to hit 0. And this is the nice thing about having an unlimited table, because you can just keep going until you eventually find where you've paid your car or whatever you borrowed the 100,000 rand for. Shouldn't be too much longer now. Okay, I was wrong. Okay, here we go. So at 98 months, you've officially paid off the car. Okay, so 97, whatever. And so at 98 months, you've officially paid off the car. So 98 divided by 12, let's just go to here. So that tells me that it took me almost 8 years to pay off 100,000 rand at a rate of 1,500 rand per month. Okay, compounded at 10%, compounded monthly. So it's a really nice way to do present values and even future values. There's so much that you can use to explore here, just by being able to change where your X is in the formula and show them the difference. You could even change your interest rate and show them the difference in what amount you would gain if you're doing a future value or a present value, depending on what you're looking at. So really lots of fun things to do here as well. Alrighty. So that is that. Are there any questions there with regards to finance? We're all good. All right, fantastic. Let's move on to our matrices. Wait, I see a question. Okay, thanks to Bang. I'm glad you're good. Okay, so what I want to show you now, and this is particularly for the AP guys who are doing matrices, the calculator is amazing for matrices. So we're just going to use 5. And the first thing that we need to do is to input a matrix. So I'm going to actually go back here and find my matrix that I was using. So here's my example of my matrix. Let's type it into the calculator. So to do that, we press math and we choose 1 for edit. And we're going to say it's a 3 by 3 matrix. So I'm going to say 3 by 3. And I just picked 3 by 3 because you can see the whole screen on the calculator. But you do have an option of up to 4 by 4. Okay, and you'll see that if you do that, it just goes all the way down and all the way across. Okay, let me change it back to my 3 by 3. Okay, great. So to type in any values on your matrix, you're just going to type from left to right and then from top to bottom. So it's left and then left and then left to right. So we have 3 and then equals, 7 equals, minus 2 equals, 8 equals, negative 7 equals, 4 equals, 1 equals, 0. We can just skip, so press equals, and 5 and equals. Okay, so those are your matrix values. When you're done typing them in, I see lots of questions popping up now. Just give me a sec. What we're going to do is store it into your matrix. So we're going to say 3 and 0 for store. Now, if we want to use the matrix, the long way around for that is to say math, 0 for matrix and 0 for matrix A, and that will pull up your matrix, or you can do a calculation. Okay, let me answer these questions. Gugu, yes, there is a manual. I will send it to you. Anna asks, will the amount next to 97 be your outstanding balance? Yes. So this is to go back to the present value question. Yes, that is your outstanding balance, because we're using the same calculation. We've just moved the p-value. So you're just solving for the n outside of that, and it's just working out your balance as you pay off whatever you've borrowed. Okay. Now, if you want to do lots of calculations with matrix A, there is a very nice shortcut where you can say store into your D1 button the name of your matrix. So if you're doing lots of matrices work, instead of having to go math, blah, 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 you can just press D1. And we can, oh, there's your inverse. So let's find your inverse. And voila, there's the inverse of your matrix. If you want to get the determinant, we press math and 4 for determinants and D1 for your matrix name and equals. And our determinant is -371. And of course, there's so many nice things. You can say 6 times determinants. You can add the matrices together. So what we could do is take this matrix and actually store it into matrix B. And then we have matrix A times, haven't saved that name, so I'm just going to have to do the long way, matrix B and equals. And now we've got that. So the matrices are very easy to use, as you can see. Now, of course, if you look at your menu, you've got your determinant, your transpose of the matrix. So you can say 5 matrix name equals, and it will just shift your matrix around for you. You've also got wonderful things called identity matrix. So you can tell the calculator you want an identity matrix with a 3x3. You can fill the matrix. You can have a random matrix of a certain size. And then these here are row echelon form and reduced row echelon form. And so what you can do is find the reduced echelon form of a matrix. So I can say A and my matrix A and equals, and there you've got your reduced echelon form of your matrix. So if I had a 3x4, I could actually solve my equations using this method as well. And in fact, you can also use the reduced row echelon form. It is in the example in these notes. I'll show you now. That shows you how to do that. So there's your row form, and of course your reduced row echelon form. So we saved a new matrix and then found the reduced form. So it actually solves your question for you. So there's your answer to the series, that linear series, linear equation graph. Of course, you can use the equation mode, which is what becomes the next. So I'm just going to briefly go through these quickly. So on your equation mode, that's number 4, you have a 2-variable linear equation. In other words, ax plus by is equal to c, and a 3-variable linear equation. So ax plus by plus cz is equal to d. I see there's a question now. Paul, yes, I will share the slides as well with you. So I just want to show you quickly the quad. The quad is really nice. So let's say we have 3, -8, and 10. I hope this works. Okay, so it's actually, it doesn't have x-intercept. So you can see it's actually given us the i's. And then, of course, you've got your minimum and max, your minimum value and your x value at that y minimum value. For the cubic graph, all we would do is say cubic, and let's just use the one we were using earlier. So 13, 34, and -48. And you'll see again, there's all my points, -8, 1, and -6. So that's pretty much what equation mode is there for. Again, it's not allowed in a DBE maths exam, so you just need to be aware of that as well. Puling, I will include you for the slides as well. All right, so that's all the steps. Let me say thank you to the guys on YouTube for watching and recording.